Hey there, I wanted to give you just a real quick video on this whole thing about building a uh, adjustable capacitor, a variable capacitor. So what we're talking about is building a parallel plate capacitor out of two pieces of foil. So we've got plate one and plate two. Um, the really cool thing about trying to build this thing out of foil is that we can really easily control the parameters for capacitance, which depends on things like the area of the capacitor and the separation between the plates. So in terms of varying the separation in the capacitor, what we're basically talking about is sandwiching something like a sheet of paper, or you can go get two sheets of paper, or you can just fold the paper in half, and now you've got two sheets of paper, right? So we can build variable capacitors where we change the thickness, and we can also adjust the area. And so what does it look like to adjust the area of the capacitor plates? Well, if we just focus on adjusting one of them to keep life simple, it could just be as simple as folding the foil in half, and right now, essentially, we've got a small plate on top of a big plate. But we could fold both in half if we wanted, and now we've got two parallel plates that are half the area, right? So we have a very easy way just by folding the foil to adjust the area, and by putting more sheets of paper to adjust the separation between them. So in terms of turning this into a circuit, all we have to do is get our humble breadboard, and according to the circuit diagram, I am using a 100 kilo ohm resistor, and with that 100 kilo ohm resistor, we are going to hook up the parallel plates. So this will be my bottom plate, and if I want to connect up to it, what that looks like is just grabbing it with one of these alligator clips and plugging it in to the same row as the resistor. So, all right, so I've plugged one in to the same node as one side of the resistor. The other plate is going to be attached to ground. So basically this capacitor in the circuit diagram goes between ground and the node where it connects up with the resistor. All right, so let me connect that into the ground pin. All right, and now all that remains to do is to just hook up the open scope. So, right, I want to measure the voltage across the capacitor. So that means I have to measure between, the two opposite sides of the capacitor, and that is my oscilloscope channel 1. And then I've got a ground pin here, which I used a black wire, so it's easy to remember it's ground. So that's getting plugged in to the circuit diagram also. So this basically is the measurement, but of course we also have to drive we have to drive the RC circuit just like we did in any of the other cases. And right, so it's basically the exact same circuit diagram as before. The only difference is it's a capacitor that we're building rather than a pre-built capacitor, right? So then I can go over to the waveforms instrument panel. So this is the RC circuit. So it's a lot like the same kind of response that you were seeing for the, like say, the 10 nanofarad capacitor, except this is a home-built capacitor, and we can demonstrate some things really easily. So for instance, as I kind of flatten out the capacitor and bring the plates closer and closer together, what happens is it would appear that the capacitance increases, and so the decay time gets longer. On the other hand, as we stick multiple pieces of paper, so in this case I fold the paper in half and I stick it there, or if I just kind of generally relax my hand so the spacing gets larger, the RC time constant gets shorter, so it decays faster. So bigger capacitance, smaller capacitance, bigger capacitance, smaller capacitance. That's basically just me closing that gap between the folded sheet of paper. So kind of squeezing the fold tighter, letting it open up. And so, yeah, so I mean, that is very similar to how the DMM estimates, different capacitance levels. And here, just by adjusting the area of the capacitor by folding or by changing the thickness, you can kind of see these qualitative trends. And we're not trying to get quantitative, just qualitative with this, but that's the basic idea. Hopefully that helps.